Yes, hello everyone. It's a pleasure to talk to you today and present a little bit of Adastra and a little bit of one use case that we developed for a specific company. Yes, my background, I'm actually coming from a scientific background. I did a PhD in bioinformatics, had some research on viral RNA structures, and then somehow stumbled into Adastra, which is a nice data analytics company. And yeah, the head of practices, again, I'm head of all the practices. I'm responsible for the staffing of projects, for the know-how of our consultants, and for the directions we actually develop our company into for the market of Germany in the end. Okay, today, the title from my presentation today is From Scattered to Orchestrated, an Agentic engineering cockpit for product development. Basically, what do we want to do today? I want to present you a little bit about what is Adastra, who we are, what we do, and what we offer for you as companies in the end. But that's just in a limited context. And then I want to show you a real-world example of a use case that we implemented for a specific customer. I will not be allowed to name the customer, but it's one of the big automotive OEMs in the end. We will walk through, and there are not that many in Germany. So again, I will just give a little bit about the context of the problem statement, what we faced, then a little bit about the solution that we actually implemented, and what the benefit for the client here is. And as a last point, a little bit outstanding, but due to the recent development, I want to talk a little bit about the AWS European Sovereign Cloud, simply because it is becoming a topic and it is launched actually at the end of the year. And I want to give a little bit insight of what this means, what opportunities it opens, and we can just use that also as a discussion point for later on. Okay, let's get started. Adastra. Again, I already told you we are an international IT consulting company. From the size perspective, we are around about 2,200 employees. So we really try to combine the best of both worlds. We try to be thought leaders in our fields, data analytics and AI, and at the same time offer these global capabilities with nearshoring, offshoring. We have several offices in Germany. As you can see, our main headquarter in Germany is in Frankfurt, but I personally am originally from Munich. I'm living in Munich. We also have an office there, and our global headquarter is in Canada, Toronto. But again, we also do nearshoring from Greece and Bulgaria, and offshoring from Thailand, Colombia, and India. We are in the market for more than 20 years. We actually had our 25th birthday a couple of weeks ago and celebrated that intensely. We serve all the industries, and what we really offer is we have a clear focus on data, analytics, and since this is a big hype, also AI, obviously. But I completely agree with my predecessor. You can do use cases as many as you want. They will only be successful if your data foundation is correct and is actually supporting the use case and solid. So what we do really is we offer anything from data strategy consulting up until cloud migrations, of course data mastery, including proper data governance, data security, and of course business intelligence, and as I said, AI, right? Okay. Let's talk about this actual use case. I don't want to waste your time just talking about my company, or not my company, our company in the end. Let's go into the details of this actual use case. So the problem statement here was, again, I already told you it is about an automotive company. And there is a specific concept that this engineering process in automotive actually follows. It's called the V concept. I don't know how many of you are familiar with it. In the end, I will give a brief explanation what it means, because it kind of outlines the actual problem. And I think this is a problem that many of you are also facing, even if it's not in automotive. So basically, it simply means that we have to, when we define each step of the engineering process, right away have to also define the validation of this step. So let me try this feature here that was introduced to me. Yes, exactly. So when we define the requirements, at this point, we also have to define the validation of these requirements. So we have to, on the process of telling what we actually want to build, we have to tell which tests we need to prove that the requirement is also fulfilled. And this is true for all the steps. Now, this leads to very separated systems where we do the documentation of these steps. So let's say we have the requirements in a specific database. Could be AIDA, Octane, Jira, name all the ticketing systems, right? Then the next step here is analysis and architecture. We want to build an architecture, can be a car architecture, can be a design architecture, design pattern of a database, doesn't really matter. The documentation again is in another ticketing system. Then we have design planning phase. Again, we define the requirements here in the next ticketing system, and again the validation of these requirements in a testing system. In our case, the first point, for example, was in AIDA, which was defining the requirements of the car that was to be designed and produced and engineered. Then we had Octane as a system for the testing of these things. And basically, you can imagine that the data is scattered in these systems. Within the systems, we have very well-maintained metadata, and everything is well connected, everything is well described. But between those systems, it is very difficult to get actually the connections. And now the actual problem comes if we have to change something during the engineering process. So we reach a certain degree of maturity and something changes, whatever. In China, we are not allowed to use a blue light anywhere anymore. Right? So what effect does that have? We have to go back into these different systems and see what effect this has. So we have to connect the dots. And this is a highly manual process in this regard in the end. So what do we need? We need actually a unified access for all these systems to actually bring the data together. And we need these connections between the things to get the data lineage actually. What effect do I have if I change one parameter during the process? Again, just to outline the problem statement, we have different engineering teams working in different siloed ticketing environments or specification systems, testing systems. And if you ask any engineer during this process actually a simple question, but it needs data from the different systems, it takes hours or even days to simply answer that question. And the idea was to create a unified layer which enables anyone working in this process to access all the silos basically from one unified access point or interface, and answer these questions, of course, in a, let's say, faster way than before. So, again, outlining the goal. We wanted to build something which we called AI-powered engineering cockpit. What I mean with this, as simple as that. We want a website which is able to access all the different documentation systems from one place. From this engineering cockpit, we wanted to be able to query all those different systems and get data back. And of course, we want to provide answers that fit best the person that asked the question, because it makes a huge difference if a requirements engineer asks a question or a test engineer, or if the COO actually wants to know how is the overall process of the car. He does not want to see any detailed numbers on whatever, he just wants to get the overall picture. So we also needed this context awareness, and of course also data governance is a huge topic in here, because not everyone is allowed to see every data point from each of the systems. And of course, the goals were to accelerate this whole discovery process, eliminate all these manual consolidation steps, automate the report generation, and last but not least, actually to also provide recommendations, because it is also very helpful if exactly that case that I outlined, hey, we are not allowed to use a blue light here and there, what do we have to change? So if the system would also be able to provide recommendations even on former engineering processes. Hey, what did we did back then if this device failed, or did actually a new device match to the architecture that we have built? Things like that. So in the end, summing up, we wanted to reduce the time to insight by using AI. Just outlining what we did, and then I will show a very high-level architecture. In the end, we provided here an AI-powered interface. So the people accessing that interface were able to talk to the interface in natural language with a chatbot. We kept this role-based context awareness, so we created actually agents for each of the personas that we assumed would access the data: a test engineer, a requirements engineer, a business person from the different departments. And we provided real-time summaries and recommendations for these different personas in their roles, what they would be interested in. So we really changed the output of the tool based on who is actually asking the question. Of course, everything is accessible from a unified data layer. So we have in the end created ETL connectors to all the data sources. We provided search mechanisms, both in lexical and semantic ways. And one very cool feature that I want to highlight is the knowledge graph relationship mapping. I already explained to you that within these systems, the documentation and the metadata is very well maintained, while between the systems it is not. So if we want to model this engineering process of a vehicle from end to end, we actually need to tell the system how the dependencies between those systems are, because it will not know how Jira and Octane are interlinked and what the data in the different systems mean actually. And the knowledge graph is, well, it's not actually new. Graph technology is out there since quite some time, but using knowledge graphs in the context of AI is kind of a hype scenario at the moment, and it works quite well because of these different algorithms that you can do with graphs, finding clicks, shortest path algorithms, things like that. That's actually changing a little bit the how you treat with AI the different systems. Exactly. And of course, it is one of the few multi-agent systems that are out there at the moment. We are quite proud of that. We also reached the AWS Agentic competency since recently by doing such implementations. Which is also kind of very cool. And I will now quickly show how this looks like. Again, this is very high level. If we have deep tech people here, they will just laugh at me. This is not a real architecture. But to understand what we actually built, it's quite well outlining the idea. So on the top here, you see that we have just something steering the chatbot UI, which is an EC2 instance. Of course, some authentication mechanism to see which user is actually asking the question. We need to get this role-based context awareness of the tool. Then we use Amazon Bedrock for all the different agents. And in the end, on the top, we have a planner agent, which simply does the orchestration of the different agents. Which agent do we actually need based on what question is asked? Then we have the manager agent, which is actually spinning up the different agents. Again, I told you we have one agent asking the question, and I have to stick in this area. Sorry, I almost left it. Exactly, we have here one knowledge graph agent. This is exactly what I just told you. This agent will see in the database if the question needs several source systems and how the relation between those systems is in the end. Is there something that has to happen before the other system, like the requirement definition is here and the test for that validates actually this requirement, stuff like that. Then we have, of course, an SQL agent, because a lot of data is scattered in different tables, and you need to be able to ask questions referring to SQL tables, so structured data. And now the final agent that I want to highlight here is the retriever agent. So I told you that we have data in all these different ticketing systems. And what we did was, in this case, this is just one possibility, but for this use case, it was the best choice in the end, was we ragged that data. So we created a vector database where we put all the contents of the tickets inside. And the retrieval and the search in the vector databases is just much faster, as if you would parse the complete data sets all the time, because you have indices for those databases. And that just changes a bit the runtime and the retrieval time of these agents in the end. So what will now in the end happen is that someone asks the question, the planner agent will try to dissolve this question into the different parts that the answer will need. The orchestration agent or managing agent will spin up the agents that is needed to actually structure the response, ask those questions to the different source systems, and then it will just be consolidated back to the managing agent, and the answer will be structured in a way that it will fit the role of the person that asked the question best. That's the idea of the tool, and well, the outcome in the end was surprisingly good for us in the end. Again, just to summarize, we had developed this unified AI cockpit. Can't just imagine this is a website, right? It's just a web page where people can ask a question, and based on their role in the company, the tool will already know what their context is. It's a multi-agentic architecture, which is actually really speeding up the time to insight. And the first measurements in this case were really, we changed on average from hours to seconds, right? So because we can answer complex business questions in the development process of a car. And you can imagine in these huge old style German OEMs, the development process of vehicles takes around about 7 years. And this is one of the first steps to keep up with the Chinese competitors customers in the end and reduce this time by making this process more efficient and answering questions much more efficient than it was possible in the past. And of course, the whole solution is scalable with a serverless foundation, right? That's also a very important point. All right. That would be it to the Agentic system. I think this will be also the main topic for the roundtable later on. If you have any questions, ideas, or want to get some insights on your companies, on your systems, we can just have a discussion on the roundtable later on. I have actually no clue how much time I have left, but I will just continue. The last topic I want to highlight here is actually a bit off topic compared to the Agentic AI because it's not a use case. But I think based on the development and the regulations in the EU, we discuss a lot about what are we allowed to do. We see also a lot of hesitation in the market to move into the cloud by companies. And that's why I just wanted to use this as a chance, because this is really a topic that will become more important in the future. And it's not the first sovereign cloud project that is actually launched, but I think it's the first one from the big cloud providers that will be out there, and it's launched actually end of this year, and it's called the European Sovereign Cloud, which is from AWS. What this in the end is, AWS is actually starting a new company in the European Union, which will be completely separated from the actual AWS company. So it will be a EU-based company, and it will offer a dedicated cloud for the European Union. The planned start is end of 2025, and it's specifically targeting the European market and wants to remove the barriers to adopt into the cloud for specific markets which are hesitant to adopt the cloud because of having issues with data resilience in other countries and stuff like that. So in the end, the idea is providing digital sovereignty, which is completely hosted inside Europe, especially relevant given the EU regulations. But again, now it's not the first project. The difference here will be that this is actually already established cloud provider offering the full AWS capabilities, but keeping also the sovereign compliance, right? So no compromises compared to a normal cloud, but being compliant with all the EU regulations. So basically, the key industries that AWS states here are also these highly regulated markets where we have financial, healthcare and pharma, government, public sector, telecommunications, R&D, of course, and last but not least, defense and security. But I assume there will be use cases in all the industries in the end where we think a lot about data sovereignty inside the European Union, and this will become more and more important. We, as Adastra, I will skip that now just due to the lack of time a little bit, but I think we can talk about that also at the booth later on. I have even a couple of more slides for each of those points to highlight what this actually means, what is the benefits of the European Sovereign Cloud in these different areas. And I just want to highlight that we as Adastra are one of the launch partners in the AWS European Sovereign Cloud. We have a very close collaboration with AWS. I already highlighted that we are a premier tier services partner and have basically early bird access to these tools, and we'll also get some upfront information how the implementation will work. You can imagine that not all the services that AWS offers will be available right away. So there will be, of course, some benefits that you will have talking to one of the launch partners, because those people will have the ideas of what will be available right away and what is the roadmap when these features will become available on the long run. Of course, we have also experience in working in these highly regulated environments. We are serving customers from all the industries, basically, being it banking, pharma, and we tackle these GDPR and DSVGO regulations all the time. So this is not new to us. And we are also experienced in providing these end-to-end solutions in all these different markets. With that, I would just like to thank you. I hope you enjoyed the presentation. And yes, if you have any questions, feel free to come to our booth, join the roundtable. I'm happy to answer anything. Thank you.